Hey everyone, welcome to CE Chat, hosted by Cloud OnAir, which hosts live webinars every Tuesday about Google Cloud. My name is Stephanie Wong, Cloud Customer Engineer, and today I'm super excited to introduce you all to Ryan Frisbel, who is a networking specialist and customer engineer here at Google Cloud as well. So, Ryan, did you want to introduce yourself really quickly?
Sure. As Stephanie said, I'm Network SME for Google Cloud. So I spend most of my time talking to customers about all things cloud networking.
Awesome. So just to remind all the live viewers, you can ask live Q&A throughout the segment on the Cloud OnAir platform, and we will have Googlers help answer them throughout, and we'll also have some time at the end for Q&A as well. So without further ado, let's get into it. I'm super excited today to talk about networking, which is such an important foundational concept to understand as people begin to think about moving their workloads to the cloud, especially when they're trying to map out their on-premise network topology into something like a software-defined network on Google Cloud. So Ryan, take it away.
Sure. So networking is obviously a very broad topic. It's not something I can cover in the next 30 minutes. So I wanted to lay out a quick roadmap of what you can expect today, and then follow-on sessions that we have planned. So today, I'm going to talk about the VPC construct, or the virtual private cloud. I'm going to talk about a concept that Google has done called shared VPC. And I'm going to also talk about, once you build these VPCs, how do you actually connect to them from your on-prem or data center locations. During the next section, we'll cover routing or VPC peering. Next, we'll move into firewalls and security. We'll also plan to have a session on load balancers and all the flavors that Google has and how to use them in the cloud environment. And then we'll cover other services. If there's something networking related that you want us to cover, please let us know and we'll figure out how to integrate it into these topics. So with that, let's jump into it. So for anybody who's done any work in the cloud, this probably looks very similar to you, right? This is sort of what I call a traditional VPC. So if you've used AWS, if you've used other cloud providers, this is sort of how it's built, right? So what I'm showing here is two VPCs that have been built with two different subnets. So as you know, when you build VPCs in this manner, the way that VMs in, say, US West talk to VMs in US East is typically through VPN gateway, right? There's no way to actually have direct communication between, say, a web front end that's sitting in US West and maybe a web back end that's sitting in US East, other than going through that VPN connection. So Google thought about this topic and we said, OK, how can we potentially do this different? How can we simplify this? And we came up with Google's version of the virtual private cloud environment. So in Google's world, the VPC, the container with which in the subnets live, is actually a global construct. So instead of having to build a VPC in US West, a VPC in US East, a VPC in, say, EMEA, you actually build one VPC, and then you actually put subnets in the different regions within that VPC. Now, as you see here, there's no VPN required to actually have a VM in US West talk to a VM in US East. This is all handled by Google in terms of routing that we have under the hood. So it's nothing that you have to do. Now, you can control this through a lot of means, through like firewall rules and various other things, which we'll talk about in other sections. But really, from a conceptual standpoint, it really simplifies the environment as you're deploying things.
So just to highlight that again, you're saying that we don't need a VPN for traffic between regions. How does Google do this?
So we do this through Google's underlying network. So this is the same network that we use to run our search engine, to run YouTube, to run Gmail. All that infrastructure that Google has built for our own use, we actually use that as part of cloud, right? So we use that same network infrastructure to move traffic from, let's say, VMs running in US West 1 to, say, a VM running in EMEA.
Wow, pretty revolutionary.
Yeah. So really, why is this concept important, right? So one, it simplifies the network, right? So as I said, you have one global private networking space with then regional segmentation to put your subnets in, right? I talked about the VPNs. So if you look at the picture that I started with, it's very simple when you're dealing with two VPCs and, say, a couple projects. But imagine expanding that model to hundreds of projects, all running hundreds of VPNs. Now you've got mass amounts of VPNs that you're building. You've got mass amounts of VPN gateways that you're trying to stitch together. When you do it with Google's method, you don't need to use a lot of that infrastructure. So it really simplifies that network stuff, which your network engineers, your networking engineering organization will love, that simplification. The same thing applies to routers. So what I didn't show there is in each of those VPCs, you actually have routers to dynamically advertise routes. So in the traditional environment where you're building a VPC in the West, you're going to put 1, 2, maybe even more routers in that environment. You're going to put some more routers in the VPC in the East, more routers in EMEA. You're going to use those across the VPN tunnels to provide dynamic advertisements for your subnets. So you can quickly see you've got a lot of sprawl in terms of the routers, the number of BGP sessions you're managing. It tends to grow and grow and grow on you. With Google's construct, you don't need to do that. You can actually put a couple cloud routers in place, right? So if you're trying to stitch together multiple VPCs together, you actually can just use a couple cloud routers to do it. So have these very large global routing domains and not have router sprawl where you have hundreds of routers. So it really simplifies just that network infrastructure component of things. Second, it simplifies management, right? So you can think about if you have all these VPN gateways, if you have all these VPN tunnels, what's happening is when something breaks, you have to go and figure out what is broken, where is it broken. You're looking at potentially different cloud routers, you're looking at different VPN tunnels, you're looking at different VPN gateways, you're looking at the A side, the Z side, because you have all this stuff stitched together in this very complex mesh, right? With the Google environment, it's much simpler. So when something isn't functioning, there's only a few things to really look at and sort of dissect what is working and what isn't working, right? So it really simplifies that operational management. The other part is the security policy. So if you ever spun up VPCs, you know that the security policy typically is constrained to that VPC. So again, if you have a VPC in the West, a VPC in the East, a VPC in EMEA, you're managing separate security policies for all of those VPCs. So if you're a security administrator and your goal is to sort of unify your policies and have a very uniform policy applied across many things with maybe slight tweaks in each of them, it becomes more difficult to manage that uniformity because you're having to copy and manage 12, 15, 20 of these things, right? In the Google environment, because that VPC container is global, you can really manage one security policy, right? So it simplifies the management of that as well. The other part is flexibility. So you can build exactly what I showed in that first slide, right? You could build a regional VPC construct, right? And just drop a subnet in one region. And build a second VPC and drop a subnet in another region and actually connect those with VPNs, right? Just like you would in a very traditional model. Or you can use the Google model, right? Where you have this global construct and dropping different subnets in different regions within that VPC. And you could actually combine them, right? You could have some that you're using that global VPC presence where you have a lot of subnets. And then you could also be using specific VPCs for specific applications that are really constrained to just one region. So Google is really giving you that flexibility. Every business is different. Every business is unique. So what your needs may be different from your competitor's needs or another business down the street. So we've given you that flexibility to really look at how you want to use cloud networking and to be able to apply that into Google's cloud in a lot of different fashions.
Cool. With all that said, you did mention just the use case for having individual subnets in each region. So is that sort of a use case for not using that global VPC construct?
So here's a good use case for not using the global VPC. I was working with a customer a few weeks ago that had very specific requirements around the applications they run have to only live in that particular region, right? It's not necessarily through something like GDPR or other things like that, but this is actual contractual obligations they make with their customers. So while we presented the idea that they could, in theory, run a global VPC and use firewall rules to constrain what can talk to what, they really didn't like that idea, and they really wanted to create these constrained network domains. So what we ended up with is actually building a VPC in EMEA, only putting subnets in there, and then for other customers in APAC, we build a completely different VPC and only put subnets in APAC, right? Mm-hmm. So this gave them that very traditional way of doing things.
Yeah, but you are sort of losing that benefit of the simplification of management.
What you'll find in networking in the cloud in general is you're always making constant trade-offs, right? Mm-hmm. So that's an example of, okay, for their particular business, they had requirements they had to meet for their customers, right, in terms of contractual obligations. So they wanted to really, manage that expectation and be able to put that in front of their customers, but they did lose some of the flexibility here. Now, one of the things they did do is they actually use the global construct for a lot of common infrastructure. So they could deploy the application in a VPC that just lived in a region, but there's a lot of core infrastructure that they actually used a global VPC, and they tied each of those regional constructs back to that common core infrastructure VPC. So again, there's that flexibility. It's not an and or situation, right? You can use all of these constructs together.
Yeah, not mutually exclusive.
Yep. So these things are really simple to set up. I want to take you through a demo real quick just to show you exactly how easy these things are to set up. Okay, so for those of you that have used the Google console before, this is the sort of home page. So what I'm going to do is I've created a project called Cloud Cloud OnAir Networking 101. So this is the project that I'm in. This is the home page. So what I'm going to do is I'm going to go down to VPC Network, click on VPC Networks. Right now, there's nothing in here. I've actually deleted the default network. What happens when you create a project is you're actually going to get a default VPC that gets created with a bunch of default networks. One of the best practices is to get rid of that. Just wipe it out. In most cases, you're trying to integrate a VPC in the cloud with some on-prem environment, right? So you have a whole IP address scheme that you've got set up. The defaults generally are not designed to integrate with what you probably already have, so there's probably some overlapping space in there. So generally, I tell people the best practice is just get rid of the default VPC. So I'm going to go in and create a VPC. So I'm going to call this demo network. You have custom and automatic subnets. Automatic is what I was describing before, where it provisions a whole bunch of 10 dot space for you. Typically not that used. You're typically going to come in here and use custom subnet. So I'm going to create network 1. Here's where you select the region. So this is where that global construct comes into play, right? I didn't create this VPC just in one region. Now I'm going to drop just the subnet into one of these regions. So let's put this one in US Central 1. Let's pick an address block. OK, there's a couple other options in here. So private Google access, this is what enables your VMs to actually talk to Google APIs without having to have a public IP address on them. So a lot of customers don't want any public IP addresses on their VMs, but they still want to access Google services, right? So this could be BigQuery, this could be Google Cloud Storage buckets, this could be all the services that Google has to offer. So if you don't have this turned on, you actually have to have a public IP address, because most of those services, as you're probably familiar with, rely on public APIs, right? So a best practice is to turn this on.
If you were not to use that option, do you have to have a public IP for the VMs that you deploy?
Yes, if you were to not use that option, you'd have to have a public IP address on there to say, like, access your storage bucket or access BigQuery or access other things. OK.
And for the /24 address range, is it possible for you to use overlapping IP ranges if you were to create 2 subnets in one VPC?
So you can't have overlapping IPs in one VPC. But let's say I created 2 separate VPCs. I could actually create exactly duplicative VPCs. I could have the same addresses in VPC A as I did VPC B. Now, that could cause problems for you as you go to interconnect these VPCs. So if VPC A needs to talk to VPC B and it has overlapping space, now you've got a problem. You can't do that, right? Because it's not going to know, where you want to route this stuff. Right. So generally speaking, you're not going to have overlapping IP space. And the same thing applies to your on-prem environments or your data centers. You're going to sort of use separate IP space. Yeah. Typically 10 dot space is what we see in the cloud environment.
Some of those same best practices apply here too.
Yep. Yeah. OK, so I'm going to click done on that one. And I'm going to add another subnet. If I can spell it right. So I'm going to create another one. This one I'm going to drop in US West. I'll call this one. And again, I'm going to turn on private access. I'm going to turn on flow logs. Flow logs are another sort of best practice. Flow logs are actually what enable logging of the actual flows from your VMs. So again, if you want to capture those flow logs, you have to enable flow logging in this environment, right? But again, it's a best practice to turn it on so you capture all those flows. They get pushed in the stack driver, and that you can use them for troubleshooting. You can use them for a lot of other things if you're troubleshooting security, things like that. I'll talk about this a little bit next time, but I want to talk about regional versus global routing. So in this environment, you can actually set up your routers to actually just advertise the routes, so the subnet that I'm created here, in the region that the router lives, right? So for example, I created one subnet in US Central 1. If I put a router in US Central 1 and I had regional checked, it would only advertise the subnets in US Central 1, right? Generally speaking, what I see is people using global. What that really means is I could put a cloud router anywhere in this environment. It's going to advertise all the subnets in this environment out to wherever you're advertising. So it could be your on-prem, your data center, things like that, right? So again, it's another, I don't want to say best practice. There are use cases to use regional routing, but generally speaking, most customers are using global routing. So now I click create, and it's going to go and create my subnets for me.
Are there any limitations on the number of VPCs that you can have in a project, or the number of VMs in a VPC or in a subnet?
So let's take those one at a time. So number of VPCs in a project. So we have the concept of quotas and we have the concept of limits. So let me touch on those real quick. Quotas are generally something that can be increased. Limits are something that are generally hard fixed, right? So we have a quota for VPCs where you can put 5 VPCs per project. Now that's a quota, right? So you can go and request an increase to that quota to be able to put more VPCs in that project.
Right.
You're asking about number of VMs in a subnet, right? Every VM is going to have an IP address in that subnet. So in this case, I created /24 subnets. So you're going to be limited to, 1 IP per VM is going to dictate how many VMs you can put in this particular subnet. Right. If I were to make this, a /20 subnet, I could obviously put more VMs into that subnet.
Okay, makes sense. Yeah.
So there we go. While we were talking, it created my 2 subnets for me. So literally, it's that simple. You just go in there and populate whatever subnets you want in this VPC. You drop into whatever regions you want them in, and it auto creates everything. And now you can go and create compute engine environments, create whatever you need using this IP space. So let me go back to the presentation here. OK, so I want to expand on the concept of the VPC. So this is something else that Google's pioneered, and we call this the shared VPC. So as I talked about before, you build this global VPC construct to really simplify your network, to simplify your operational management, right? Shared VPC allows you to take that simplification even further. So what I'm showing here is this blue box is actually the VPC that was created, right? So there's various subnets within this blue box. Right? I could have more blue boxes in this gray box. This gray box is the project, right? So when you use shared VPC, projects become 2 types of projects. You either have host projects, and this is where your networking resources are actually going to live. So when I say networking resources, I'm talking about your cloud routers, your VPN gateways, your subnets, things like that are going to live in the VPCs in that host project, right? On the right over here, I have got a few example projects, right? So I've got a recommendation project, I've got a personalization project, I've got an analytics project, right? These are what we call service projects, right? So if you think of the traditional model, I would spin these up as a project, I would put VPCs in there, right? So I would have VPCs in the recommendation project, I'd have VPCs in the personalization project, I'd have VPCs in the analytics project, I'd have VPN gateways, I'd have all the VPN tunnels, I'd have all the cloud routers, I'd have all of this stuff, right? So this is sort of that sprawl I was talking about, right? So the global construct allowed you to eliminate some of that, right? The shared VPC is going to allow you to eliminate even more of that or simplify your network even further, right? So in this example, I've got all of these subnets that I've created, again, in one VPC. Now what I'm doing is I'm not actually creating any VPCs in these projects, right? So the recommendation project, the personalization project, those actually don't have any VPCs that are living within the actual project themselves, right? What I'm doing is I'm actually sharing the network infrastructure from the blue box, that shared VPC, into those projects, right? So the users of those projects, right, they're not creating any network, they're not using a network that's central to that project, they're actually using network from the shared project, right? So the way you can think about it is your users, right? So a development team, the people who are spinning up VMs and doing operations in these projects, they're touching the VMs in the small gray boxes, right? Like the recommendation project. Maybe this is your production environment, right? Typically, the people that are operating in the blue box are your network engineering staff, right? Your network security team. They're managing all of that network infrastructure, and those are the only people that are really operating within that environment. So it creates a very clean separation, right? You don't have a bunch of hands in there that potentially can break things or mess things up for you, right? It's just network engineers, just your security teams, right? And then they're pushing that infrastructure out so other people can actually use it, right?
So from an IAM perspective, this is giving you that segregation of duty and
correct. When you use IAM rights, right, you're going to have network administrators, you're going to have network users, you're going to have all that stuff, right? So most of your network or infrastructure administrators are going to be operating in that blue box, right? Whereas your users and the guys that are consuming the network infrastructure by building VMs, by building other sort of network things, they're going to be in the recommendation project, right? So they're not actually going to have the ability to do anything but, say, drop a VM into that particular subnet. They can't change the subnets. They can't, create more subnets. They can't do any of that stuff. They can only create VMs within the subnet that you've given to them.
Right. Alongside that kind of idea of least privilege, best practice.
Yep. And then on the right side of this drawing, I'm also showing, so you've got all those VMs that have been created off that shared infrastructure, right? They're accessing various APIs, right? So I'm showing a machine learning API, analytics, sort of BigQuery API. So those VMs are still able to do that. Because remember, we set up that Google Private Access in the blue box VPC, right? When we set up that VPC, So all that stuff carries down to those service projects. Now, the other thing that's really nice about this is we talked about your security domain, right? And we talked about your unified policy. So in this case, I'm writing one policy in that blue box. And when I extend all of those subnets down to those service projects, the security policy actually goes with them, right? So now you've got, instead of having to build all these individual VPCs across all these different projects, you've been able to centralize your VPCs, right? You've been able to centralize your security policy. And now you're able to scale to hundreds of projects, take that infrastructure, push it down to those projects, take that security policy, apply it to those projects, right? And your security policy, you may have specific rules that apply, to just the recommendation project or just the personalization project or just the analytics project, right? But you still only have one policy that's written in that blue box, right?
Right.
And you're applying certain parts of that policy in maybe the analytics project or the personalization project or the recommendation project.
Yeah.
But again, when you think about unifying everything and only having to look at one policy, it really simplifies that.
Yeah, especially from a security perspective, a management perspective, and just adding to that scalability.
Yep. So really, it sort of continues on that theme. And this is, if you take anything away from today's talk, it's really about how do I simplify my network? How do I simplify the management and the operational day-to-day functions? And how can I sort of use a lot of this flexibility that Google gives you, right? Whether you choose to do it in a very traditional manner, you decide to use some of the functionality that Google has really created to really allow you to simplify this stuff, right? That flexibility is sort of key, and it's something that we're really happy that we can provide. So again, simplifying the network, right? You're now able to deploy that VPC across many projects. So you could have a single project with a shared VPC, another single project with a shared VPC, but this allows you to have just one project, push that shared VPC to hundreds of them, right? As we talked about before, fewer networking elements, because I'm building the routers, I'm building those subnets in the host project itself and in those VPCs. Again, I'm not having sort of that continued sprawl of things. Again, I talked about this, simplified management. You have one security policy that you're managing, and you can manage this across hundreds of projects.
Is there any upper limit on the number of service projects that you can have under one shared host project?
So there's no hard limit that we've seen. So we've tested up to 5,000, right? And it runs fine. The quota is 100. So you can do 100 with nothing, no issues, not having to come to Google and request anything special, right? But if you want to go beyond 100 projects, you have to put in a quota increase. But again, in terms of limits, we've tested up to 5,000. We've had no issues. So yeah, we don't really necessarily know how big this thing could potentially scale.
All right, well, if you have 5,000 projects, then you're in good hands.
So like I did before, let me quickly show you how easy it is to set up just the shared VPC aspect of things. Okay, so I'm back into my project where I built my two subnets. I'm going to go into, under VPC network, I'm actually going to go down to shared VPC. So this is the menu when you're actually setting up a shared VPC and what this piece looks like. So on this first part, I'm going to get to specify, because I'm in this project, this Cloud OnAir Networking 101 project, I'm going to say, yes, I want to use this as a host project, right? Here I can check whether I want to only show shared subnets or all subnets, right? And over here, I'm actually going to attach projects to it, right? So I'm going to go ahead and attach a project. So I've created a second project, this Cloud OnAir 101 shared VPC, right? So this is the recipient. So this is the service project that I'm creating now. I defined the host project in that first tab. Now I'm defining the service project. So I'll go ahead and click on that. Here you have the option to either share all subnets. So I created two subnets in there, one in the US Central, one in US West. I could just by default share all subnets, right? Most customers that we work with are going to share individual subnets, right? So maybe their service projects are a production project, a development project, a testing project, and they have different subnets carved out. So they don't want to share all subnets with production and all subnets with testing and all subnets with dev, right? So what they're going to do is click, I want to share individual subnets. So let's say I was using this as a production environment and I created my two subnets, but I only want to share one of the subnets. So I'm just going to click on that, save it.
You really get that delineation there if you don't want to apply all subnets.
Yeah, you can sort of really get that granular level you want, right? Again, if you want simplification, you can say, I'm just going to apply all subnets. If you want sort of to granularly specify things, you can do that too.
Yeah.
So again, it goes back to that sort of flexibility. The way we've engineered this is to really be flexible because, as I said earlier, every business is different. Every sort of networking construct that we build with different customers looks slightly different, right? Because they all have different use cases. Okay. So now I can go into my service project. So if I go into my service project and I click on VPC networks, you can see there's actually no VPC networks I've created within the service project, right? So I haven't done what I did in that very first step where I've actually built a VPC. I didn't do any of that, right? All I did was really go in and share a subnet with this, right? So now you're going to see these two options, right? So now you're going to see networks that are shared with this, right? So here you can see the two networks that I've specified here. Both of the networks are showing up, but I've actually only shared one of them. So if you go back to the other environment, and I go into the shared VPC menu, so here it says network 1, 3 users, right? So 3 users are all my user identities, right? Even though network 1 and network 2 are both showing up under that other VPC, I've actually shared one, right? Because I can only see 3 users there, right? So if you look at this, right? So I actually drilled down into the actual shared service, the service project, right? Again, you'll see both networks, but you see there's 0 users in there, right? Because I haven't actually shared that network. So no users can actually provision any resources in there. The only network or the only subnet they can provision resources in is this one, right?
Got it.
Again, I could have created 20 subnets, shared 15 of them, or I could have created 20 and shared all of them, right? Again, it sort of depends on what your specific needs are and sort of how you're architecting the VPC components of the network.
So the number of users you see here is the number that are in the service project that you've shared that subnet with.
Correct. So that service project, I have 3 users in that project, right? They happen to all be my user identities, but you could have a whole ton of users in that project. Like your whole development team could be in there. So when you share that resource, it would say maybe you're sharing this with 250 users, right? That are authorized to create resources in that project, right?
Got it.
So again, very simple to set up. Doesn't take a lot of time. It's really designed to be very easy and simple. Okay, so now that we've talked about the VPC construct in itself, and you sort of built this construct, whether you've built it in a bunch of different VPCs, or you've used sort of Google's global VPC construct, or using the shared VPC construct, right? This is stuff that you've all built in Google Cloud's environment, right? So you still need to connect to it, right? So this is connecting from your on-prem environment or your data center or something like that, right? So this is usually the next logical step of, well, how do I get connectivity to all the stuff that I've built? So the easiest way to think about this is sort of in this cruciform pattern, right? So on the left side, you have sort of layers of the OSI model, right? So I have sort of layer 2 options versus layer 3 options. And then across the top, I have dedicated options, meaning I'm directly connecting with Google's edge, or I've got shared options, which means I'm connecting to typically somebody else's network, which is then multiplexing a bunch of customers together and then pushing all those customers at once up to Google, right? So there's some other provider in the middle in that sort of environment. And then you've got VPN, which I've sort of put over those top 2. So you can't use VPN with layer 2 networking options, but you're typically going to use VPN over the top of those layer 3 options, because most people, as I said earlier, are building private address space in there. So let's start with those top options, because that's typically the way customers start interacting with Google Cloud. So there's 2 ways that they can sort of do a layer 3 interconnect. When I say layer 3 interconnect, I'm basically meaning they're connecting with our edge at layer 3, right? So you're getting, in the case of dedicated, right, in the upper left-hand corner, you're actually connecting to a peering router on Google's infrastructure, and you're getting all of Google's net blocks advertised to you, right? If you go through the shared route, this is basically using your ISP, right? Google is connected to most ISPs globally in the world. We're providing all of Google's net blocks to those ISPs. Those ISPs are then advertising them down to you. Now, the big thing to note here is there is no SLA around either of these products, right? So the layer 3 interconnects, no SLA. So if you're planning on using this sort of connectivity option, make sure you have some sort of redundancy built into it, right? Connecting into one peering router on Google directly probably is not the best architecture if you're concerned about high availability, right? So as I said, typically customers are building 10 dot space in their cloud environments, right? So that's private address space. You can't access that directly from a public routed edge. So the way that you do that is you build a VPN over the top of it, right? So whether you're using your ISP to connect to Google, or you're actually connecting directly to our layer 3 edge, you're going to typically build a VPN over the top. So this is where you're going to go and build VPN gateways within the VPCs that you've set up. You're going to build tunnels to VPN gateways that you have on-prem or in your data center. And that's how you're going to tunnel across the public infrastructure all those private routes, right? I'll talk a little bit more next time on the routing and how this stuff can be built. But suffice to say, you're going to want to set up some sort of dynamic routing setup where you're advertising subnets across multiple VPNs or multiple interconnect methods to give you sort of a high availability connection, right? Because again, there's no SLA with these actual services, right? Now, the one benefit to the layer 3 service is right now it's free of charge. You can interconnect to Google's layer 3 edge for no cost, right? I should note that if you are doing any dedicated connections with us, whether it's layer 3 or layer 2, everything's done at the 10 gig layer, right? So if you only need, say, 500 megs or you need a gig or something like that, typically we're going to push over to the shared side. So it's typically going to be through some partner interconnect or through your ISP or something like that. So let's move down the stack to the layer 2 options. These tend to be, I would say, more preferential these days. This is really about building. Let's back up. So this is really about building a layer 2 connection, right? So these are VLANs that are being built, connect your environment to Google's environment. So with the dedicated interconnect, you're basically connecting, instead of a peering router, you're actually connecting to a peering fabric, right? So this is our layer 2 device, just like our peering router is our layer 3 device that sits on the edge of our network, right? So you're going to build a physical interconnect to that, and then from that, you're going to provision VLANs from that edge device to cloud routers that you build in the VPC construct. The same thing happens on the partner side. In this case, you're going to connect to a partner, right? Google has a whole list of partners out there. A good example, very popular one that we work a lot with customers is like Equinix Cloud Exchange, right? Lots of people have presence in Equinix. In this case, you're actually connecting to Equinix's fabric. Equinix's fabric is then connecting directly to our peering fabrics, right? But you're still really going through the same process where you still have to get VLANs provisioned, right? You still have to get that layer 2 connectivity. But again, when you think you and a whole bunch of customers are connecting to Equinix's peering fabric, Equinix is then doing VLAN segregation and sending a whole ton of VLANs to our peering fabric, right? So they're multiplexing a bunch of customers on that connection.
When is it necessary for somebody to select partner interconnect versus dedicated?
So there's a couple of use cases here. Normally, there's two real things, right? If you think you're going to use full 10 gig of connectivity, it makes more sense to go with a dedicated method versus using shared methodology, right? Because shared methodology, you're competing with other customers, right, for bandwidth, right? You can't control who is actually using that bandwidth at any given time, right? So if you and I are both connected through Equinix and you're sending a massive file at the same time I'm trying to send a massive file, we're basically competing for bandwidth. Now, we try to engineer with all of our partners to prevent that from happening. We do a lot of capacity planning to say, we should never be above like 50% utilization on these interconnects, right? So the chances of that happening are slim, but there's also a cost component too, right? It tends to be more cost effective to go on the dedicated side, right? If you're going to use that full 10 gig port than going to the partner side. So there's a couple trade-offs there. But typically, if you want something less than, full 10 gigs, or there's some breakpoint, it's going to depend on per partner on where the cost break even is. So where the layer 3 dedicated interconnects were free, the layer 2 dedicated interconnects, there's a charge for those, right? So that's $1,700 a month per port. So, if you're looking at a partner version, Equinix is going to charge you something, Google's going to charge you something. At some point, it makes sense just to go to a dedicated interconnect model.
Yeah. Are there any industry best practices that you've heard of?
So what I see with a lot of customers is that they start by turning up VPNs, and then they'll move to like dedicated interconnect, or they'll move to partner interconnect. Now, the great thing about this is just like the VPC construct, they're not mutually exclusive, right? And a best practice that I definitely recommend is actually using the VPNs in addition to the dedicated interconnect. So you can start by using VPN. You can actually seamlessly hot cut over to a dedicated interconnect or a partner interconnect, and your traffic will actually just flip over, right?
Oh, nice, yeah.
And then you can leave the VPN as a backup. So if something were to ever happen with your dedicated interconnect or your partner interconnect, the traffic will automatically fail over to the VPN. And since you've already turned it up anyways and it's up and running, why not just leave it up in place, right? So the layer 2 things actually do have an SLA, right? So the partner interconnect, the SLA is actually going to be dependent on the partner that you choose, right? From a dedicated interconnect, depending on the architecture you use, is going to dictate the SLA that you get. So if you connect to 2 peering fabrics in one metro, we'll give you 99.9% uptime SLA. if you connect to 2 separate peering fabrics in 2 separate metros, so you have 4 connections at that point, the SLA goes up to 99.99%.
Oh, wow.
So again, depending on the architecture you choose in terms of interconnecting to Google, there's going to be an SLA behind it for both the dedicated interconnect and the partner interconnect service.
Sounds like it could be appropriate for hybrid customers as well.
Yeah, there's a lot of sort of ways you can mix and match things in this environment. Where this typically becomes a little more challenging is if you have a hybrid environment, you're running some stuff in, say, AWS and some stuff in Google. I can't necessarily connect a dedicated interconnect from Google to a AWS version of this product, right? You actually have to have something in the middle. So a lot of customers will deploy a cabinet with a router or something like that in Equinix and then run the connections into that router and sort of hairpin the traffic themselves.
Got it.
But that actually gives them a cost advantage versus if they were just trying to move traffic from AWS to Google over the public interconnects that Google has with AWS, that's going to actually cost you a lot more money. So if you're moving a lot of data back and forth, it's definitely worth looking at an architecture where you're bringing our dedicated interconnect service to AWS's equivalent service and landing them on a router somewhere. So that's a quick overview of sort of all the ways that you can interconnect and how these things can be used in conjunction to each other. So with that, that's sort of a wrap for today. We've covered a bunch of sort of the foundational stuff.
Thank you so much, Ryan. That was super helpful. Everyone, we're going to be back in less than a minute for live Q&A. All right, let's get started with the first question. So the first one is, can I have a shared VPC that spans across multiple regions? And if so, how is that traffic billed?
Okay. So remember the VPC container, right? Automatically is going to span across multiple regions, right? So the first part of that question is yes, you can definitely have a shared VPC because a shared VPC is just taking that VPC construct that exists across all regions and applying it in the model where it's in a host project and I'm sharing it to other things. So absolutely you can do that. If so, how is traffic billed? Traffic is billed at a per project level. So when I'm sharing those resources to another project and that project is actually using those resources, it's actually going to get billed from that project, right, that I'm sharing it to where the VMs run, because the VMs aren't actually running in the host project, they're running in all of those service projects, right? And the VMs are what is creating all of the traffic, right? So everything's going to get billed within those service projects, not necessarily the host project in and of itself.
Okay, great. In one of your diagrams, you show 2 VMs and a VPC with different subnets in 2 different regions being able to talk to each other. Does this mean that a single VPC is synonymous with a single broadcast domain?
So I wouldn't necessarily think of it in terms of a broadcast domain, because a broadcast domain is really a layer 2 construct, right? So typically when you think about a layer 2 broadcast domain, what's separating broadcast domains is layer 3 routers, right? In this case, it's not really a layer 2 broadcast domain. You can almost think of it as one big flat routed environment, right? I'll talk about routing a little bit more in the next Cloud OnAir that we do, but really you can think about every host is actually its own router because we program routes at the VM level. So it's almost like this /32 routing domain, right? There is no layer 2 broadcast domain in this environment, right? So hopefully that answers that question.
Cool. Can I enforce security policies or other network-related policies on communication between components in the same VPC?
Let me read that one. Can I enforce security policies? So yes, you can. So within a VPC, you're going to apply firewall rules, right? So for example, I could have a whole bunch of subnets in there. By default, we're actually going to lock everything down, right? Google generally takes a trust no one policy, right? This is sort of the way we operate our own internal network, right? So we apply this same sort of security principle in the cloud. So for example, if you build a cloud VPC and you build a VM and then you go try to SSH to it, you actually can't SSH to it, right? You actually have to open the firewall rules to enable the certain ports, to enable TCP, to enable ICMP, to enable SSH. All that stuff has to be opened up. Everything is going to be locked down by default, right? So when you set up a VPC and you want to sort of control what can talk to what, you may build 5 different subnets, right? And you're going to specify, okay, I want only this subnet to talk to only this other subnet, right?
Yeah.
So you can sort of create that granularity. So I talked about that one customer that we met with where they had very specific regional requirements for their application, right? So we presented that option to them and say, you can really get very granular, right? So you could build one big shared VPC and really build a lot of firewall rules around that to say, things in EMEA can't talk to subnets in the US or in APAC, right? Again, they decided to go a different direction, and we like being able to offer that flexibility, but you can definitely get very granular, and you can define things via ports, via protocols, via subnets, right? So the firewall rules are very granular in terms of the VPC, right? So maybe you don't want to allow UDP traffic, right? Okay, then you don't open it up to allow UDP traffic, or maybe heaven forbid you don't want TCP traffic. You're not going to have a lot of communication then, but you could actually lock that off, right? So you have that capability to get very granular in terms of how you write these firewall rules to regulate what can talk to what within that VPC construct. And the same thing happens when you talk across multiple VPCs, right? You're going to have separate security policies in each. So you may connect 2 VPCs together, like I showed initially in that very traditional model. If you don't open up the security policies, you may have written security policies in this VPC to not allow any external IP addresses to get to it, right? So you may have linked them together with a VPN, but your security policies on both sides are not allowing you to communicate, right? So this goes back to that complexity and simplifying, right? If you have everything in one, you can see one security policy that you're managing. Here, you're trying to manage a security policy over here, and you're trying to manage another security policy over there, right?
Yeah.
But to answer the question, yes, it's absolutely doable. You can be very granular in this.
Okay. Depends on how your requirements go. All right, we might have time for one quick last one. Is it possible to create a mirror port in the Google network of a server to another server?
So port mirroring is something that we're working on. It's not generally available yet, but it's something that we want to enable as a feature. So it is a feature request that we have in front of our product team to say we want to enable port mirroring specifically on a large scale. Because typically when we get asked for it, a lot of times it's around security and various other things. So it's something we've asked our product team to look at, to put on the roadmap, but I don't have a specific date on when port mirroring is going to be available.
Okay, no worries. All right, well, thank you, Ryan. I think that's about all the time we have. Thank you, everyone, for joining us today. Please stick around. Our next session is protecting your workforce with secure endpoints. So thank you so much, Ryan, once again.
You bet.